Hello everyone, welcome to our webinar today. The topic, the webinar is Steel Connection Design Reinvented for Advanced Steel Users. My name is Michał Nowicki. I'm local product manager for Graitec Poland. Agenda of presentation today is as follows. I will start with short presentation of Advanced Steel and Advanced Design Connection. Then I will show what is CBFEM method and how works beam link between Advanced Steel and Advanced Design Connection. Then I will show live demo and I will conclude the webinar with a few slides with summary and remarks. Autodesk Advanced Steel is detailing software, gives structural engineers and detailer parametric elements, intelligent connection, automatic tool for steelwork. Moreover, it gives steel detailing, solution for fabrication data, and beam interoperability. What is Advanced Design Connection? The program is innovative 3D joint design solution. In Advanced Design Connection, you can design joints with complex geometry and any kind of loads. Calculation based on CBFEM method and international standards. The program available also reports and graphical post-processing. Moreover, Advanced Design Connection is integrated with Autodesk Advanced Steel, Autodesk Revit, and Graitec Advance Design. The integration is realized by a special add-on dedicated to Advanced Steel. Export of the connection from Advanced Steel to Advanced Design Connection contains members, plates, bolts, welds, and features. To start beam link, we can use one of two commands, concheck or conui. The second one starts the code check manager, where we can import connection one by one or bulk. We can make a synchronization of the connection or launch calculation. Let's go to Advanced Steel. I'm gonna show you how to export connection prepared in Advanced Steel model to Advanced Design Connection and calculate them. The export I will show on Advanced Steel model steel building. There are parametric elements and intelligent connections. I also prepared two views, one for elements in axis 6 and the second views for elements in the steel slab between axes 5 and 6. Now I will try to export joint in the roof. Now the connection is prepared between column, rafter, and bracings. Okay, now I'm using command concheck. At the beginning, I indicate the point of the connection and confirm with enter. Then I select members in the connection, column, rafter, and bracings. And then I should select plates and components of the connections, bolts and welds. Okay, after a few seconds, this connection will be transferred into Advanced Design Connection. And as you can see, the geometry is the same in both softwares. The next step to prepare the calculation of the joint is to add loads for all elements in the connection. I will add the load effects by import the values of the loads from Excel file. Okay, I jump into the Excel file. Now I'm copying all values for all elements. And paste the values into the table in ADC. Okay, as you can see, the one load effect is available. Last thing I should do is to check the welds in the connection. In the last version of Advanced Design Connection, we can use a special tool. In the operation, we can check missing welds. Now I can use Select All button to add all welds to plates and members. And now you can see that all welds are available, and now this joint is prepared to calculate. Okay, I will run the non-linear analysis. Is the basic calculation for stress-strain analysis. Okay, calculation is finished. On the left side, the program window, there are some information about analysis and work ratios of each component of the connection. Now I will jump into the Check tab. There are several types of graphic post-processing results, equivalent stress, plastic strain. Also, there are available stress in contacts. This all results can be presented on model or each element. Also presented can be forces in each bolts and the formed shape of the whole connection. On the right side of the window, we have three tabs. with detailed information for plates, bolts, and welds. After clicking in plus sign, there are available detailed calculation based on Eurocode for bolts and the same for the welds. Okay, now I will prepare the report. This report is creating from default template, and it contains values of the checks, screenshots, and explanations. Now I will show how to import the results of the forces from FEM system like Graitec Advance Design. In Advanced Design Connection, GUI is a special solution to import the forces from external joint. The joint can be export from calculated advanced design model by implemented special component. As you can see on the beam tab, there is a ADC button. Okay, now I'm back to the Advanced Design Connection. Now I select exported joint, and as you can see on the list of load effects, there are available two new sets of the loads. Okay, I return to Advanced Steel, and now I will show you how to export several connections at once. In this case, I will use Code Check Manager. I will start with a new project based on Eurocode. And as I said before, in Code Check Manager we have two options. I will have bulk export. Now I'm selecting for connection in steel slab. And after several seconds, all connections are available on the list in this project. Okay, now I will open the third connection. There is a special button for each collection or connection of the list. And of course, the geometry, this joint in Advanced Design Connection and Advanced Steel is the same. Now I'll show you how to synchronize the connection. in the connection number 3, I'm changing the thickness of the end plate from 8 to 12 millimeters. Okay, now, as you can see, there is a special button to synchronize current item. And after reopening this connection, I will check that this changes is available for the plate. As you can see, the thickness is the same as in advanced steel. Okay, now I will try import the forces from Excel file. Then I will check also the welds in the whole connection. Connection is prepared. In this example, I will show you the second option for the strain stress analysis, including also local buckling of the elements in the joint. Now the calculation is a little bit longer, but when the calculation is done, you can see that there is a new result on the list on the left side, and also a new tab on the right side. The list contains a factor for buckling analysis, and we can also show the buckling shape for each mode of the buckling. In this case, the first factor is big enough to say that there is no problem in this connection with local stability. Now I would like to show you how to make the calculation of the stiffness one member in the connection. You can make a copy of the connection in the project. Now you can see that the member number 2 is an analyzed member, and what we can to do, what we should to do to set the length of the element in the frame. As you can see in advanced steel, this beam has 6 meters, so the default values is good. Now I go to code setup and check that my elements works in braced system of the structure. Okay. Now this connection is prepared to calculate. In the case of the stiffness analysis, calculation takes much more time, so please be patient. The program calculates so long because we need to obtain an exact diagram of the stiffness. Okay, analysis is done. As you can see on the right side, there's a new tab, rotational stiffness. There is a stiffness diagram for the member number 2. As you can see, that the stiffness of the element is between the 2 lines, and in this case the member number 2 is classified as semi-rigid. And in the table you can find also the initial stiffness, and this value can be used in the FEM software for the calculation of the steel structure system. The last option I want to show you in this example is a production cost. This value is calculated on the settings available in a special dialog. As you can see, there are possibility to create your own template. You can save it, you can load it, and the template contains the values of the costs of the steel parts, welds, bolts, holes, and so on. With this solution, you can analyze not only the strength of the joint, but also the cost. Okay, I will continue my presentation using my slides. Okay, it's time to conclusions. Why CBFEM method used in Advanced Design Connection is so unique? Because the calculation based on non-linear material and geometrical theme analysis. Also, connection elements are modeled as components with a specific behavior for bolts and for welds. Moreover, contact is automatically modeled between steel elements and elements in the anchors, and also post-processing is tailored to needs the structural engineers. And the final remarks, in sometimes I think for typical 2D and 3D connection, calculation will be faster with simplest software like Graitec Advance Design Steel Connection module. I showed some possibility of advanced design connection, but there are available also capacity design and design joint resistance calculation. And in the 2 examples, I show how to import connection from advanced steel, but in advanced design connection, you can find hundreds templates of the connection and a set of tools to create your own complex steel connection. My presentation is finished, and thank you very much for your time. If you have any question regarding our software, please contact me by email. For more information about Advanced Design Connection, to download a trial version or contact with your local representative, please visit our corporate website graitec.com.